We'll look at question 51 as a second example. IQ tests are meant to be a measure of intelligence. A school administers the tests to 350 Year 9 students and gets a mean of 100 and a standard deviation of 15. Use this information to answer the following. So before I even read that question, I'm going to get my sketch going. That was a mean of 100 and a standard deviation of 15. Now, what is the probability of a randomly selected result being between 85 and 115? So if 85 is my lower limit there, and 115 is my upper limit there, my calculator, that's 85, 115, I'm going to have 15 and 100. So here we have 85, 115, 15, and 100. We get a probability of 0.6827. What is the probability of a randomly selected result being between 120 and 130? So I'll redraw my diagram. Again, 100 is my mean. I'm looking at 120 to 130. So into my calculator, I've got a lower limit of 120, an upper limit of 130. 15 and 100 are still my mean and standard deviation. And here I can see I get a probability of 0.0685. Next question. Part C. How many of the 350 results would you expect to be under 75? So remember, expected value, if you see that word expect, that's going to be the number of trials times the probability. So 350 becomes in, but we need to know what probability is. So we need to use the normal distribution again. Our mean of 100, 75 is below that, and we're looking for the expected number under 75, so I need to know the probability under 75. So we're going to do that first. My lower limit here will be -1 times 10 to the 99. My upper limit will be 75. Still have 15 and 100. And I get a probability here of 0.0478. And to get the expected number, I'm going to go 350 times that number, 0.0478. And we get 167.3. And I'm just noticing I actually typed that into the calculator wrong. It should be 350 times 0.0478. That answer didn't make sense to me. So move that decimal over one. This should be 16.73. And we want to think about rounding that because these are people after all. So we might say 16 or 17 results, giving whole numbers. Part D, how many of the 350 results would you expect to be over 128? So same idea. Find the probability over 128. So in this case, my lower limit is 128. My upper limit will be 1 times 10 to the 99. That's all the same. Here I get a probability of 0.0310. And again, expected value, n times p. So 350 times 0.0310. And we get 10.85. So 10 or 11 results. So don't forget, expected value is just the number of trials times the probability, and sometimes you've got to use the normal distribution to find that probability. And always draw your diagrams, even if they don't give you space for it. It'll be helpful.